Hello everyone, I'm Nathaniel along with Adnan here to present our final project, Roll Contendere. So if you study security or information theory, you should be familiar with the phrase, don't roll your own. This means when trying to secure an application, we shouldn't implement our own algorithms to encrypt data or hash the message. Instead, we should use the industry standard libraries such as OpenSSL that are developed by professionals in the field. However, engineers that are unfamiliar with crypto, or even with just the library itself, can come into the pitfall of misusing the API to the crypto library. This creates insecure applications because the security is not robust to modern standards or are used incorrectly altogether. To give some perspective, a report from Iowa State University shows a trend of increasing number of commits outpacing the rate of secure commits. For context of this graph, GitHub started in 2008, and this particular graph points out specifically JCA developers, which is a fraction of the 2 million developers in the workforce. If we consider other languages such as Python or JavaScript, and then consider developers who freelance as well, for the current year of 2021, we can expect a large increase of code development that doesn't focus on security. So for our project, Roll Contendere, we collected open source Java projects on GitHub, filtering the projects that have some form of cryptography being used. Specifically, we focus on projects that use the Java cryptography architecture and have mistakenly misused the API. We hope this project highlights common cryptographic API misuses and introduces developers to tools and benchmarks to help gauge the security of their application. So the first thing we'll cover is both the background and a literature review of cryptographic API misuse. First, we'll explain why we chose JCA for our survey. Reviewing the literature, Java security is the most studied, so it offered the most direction and framework to get the survey started. JCA itself is a framework built into the Java development kit as part of the java.security package. It's been included since JDK 1.1 back in 1997. Of course, it's experienced updates and inclusions since then, and the current framework has options for encryption, key generation and management, certificate validation, pseudo-random number generation, etc. JCA operates on provider architecture, which means when developing, you designate a provider to carry out the functionality for you. So in this diagram, here we have the application requesting SHA-256 for the digest. So a request from the provider, and then simply the provider returns back that same digest that was requested. So while this built-in ease of use is great for developers, people who use JCA need to be aware of the provider the JDK is using. You need to have compatible versions because the behavior could return something they don't expect. Another thing to note about JCA is that not every algorithm is specified in JCA due to the limitation of exporting cryptography in the US. Comparing to Bouncy Castle, which is an open source implementation based in Australia, JCA offers far less options than Bouncy Castle. This both simplifies our searching parameters and restricts our projects to algorithms that implement the more common algorithms such as AES. So once we identified what library we're going to analyze, we needed some metrics to determine if a code snippet was vulnerable or not. So we decided to base our metrics on a 2019 benchmark titled Crypto API Bench. This benchmark is developed in Java by Afros et al. From Virginia Tech and is intended to gauge the accuracy of static and dynamic analysis tools. They provide 171 unit tests that range over 16 types of cryptographic misuses, with a further breakdown of 40 basic tests and 131 advanced tests. From Crypto API Bench, we focus on more of the basic tests, which include symmetric and asymmetric encryption and cryptographic hashes. When relevant, we also analyze what cipher block mode was being used, such as ECB or CBC, use of an initialization vector, and the SALT that is presented. The advanced tests from Crypto API Bench focus on other aspects of security, such as HTTP/SSL and certificate validation, and while we did record those results, the number of projects that utilized that were very few. So to give more context of the survey, I'm going to highlight the most common errors that we saw and why they're exactly cryptographic misuses. The first misuse is using electronic cookbook or ECB mode for block ciphers. With ECB mode, it simply partitions the plaintext and feeds it into the encryption algorithm. Compare that with cipher block chaining, or CBC, which chains the output of the previous encryption by XORing the results of the next subsequent encryption. This is shown to leak information because if you decrypt a single block encrypted in ECB mode, you can simply do the same for the rest of the ciphertext. This comparison can be visibly shown with the most famous image shown in the bottom here. So you have the original image of Tux, and then the image when encrypted using ECB mode. you can clearly see the outline of tux in ECB mode, but if you see it in CBC or any other mode, you can see that it's complete gibberish. So then for our survey, we simply search for this string to be present and we'll mark it as insecure if we did see ECB. So here we have an example from Crypto API Bench where we defined AES with ECB mode. They pass in that string into the go function, which automatically is marked as insecure because the string itself contains the ECB mode. Next, we have the use of MD5 hashing. MD5 hash has been shown to create collisions in operations or scenarios where the same hash value is generated for two different inputs. The most famous abuse of this collisions were back in 2012, where a group of developers managed to forge a Windows code signing certificate. Using MD5 remains to be a major issue because as of 2019, 1/4 of widely used content management systems were reported to still use MD5 for password hashing. The technical reason why a collision happens is because MD5 uses the Merkle-Demard construction as presented here. The message is broken down into blocks and is similarly hashed like we saw in the cipher block chaining, where previous hashes are then fed into subsequent hashes using XOR. However, if two prefixes with the same hash can be constructed, a common suffix can be added to both to make the collision more likely to be accepted as valid, according to the application that's using it. So for our survey, we again simply search for the string of MD5 to be present, and we would mark it as insecure if we did see MD5. Here we have an example from Crypto API Bench where they try to hash ABCDEF with the MD5 hash. Now that we have the background covered, we can now move on to how we implemented the project. So for the implementation, we simply scraped from GitHub using Python's BeautifulSoup library. We pulled from trending in any project that was listed on the Java category. Once we had an initial pool of projects to pull from, we used another tool from Rivew to detect usage of cryptography along with any import for the Java security package. Rivew's CryptoDetector outputted the analysis in a JSON format detailing the files that contain the cryptography and other metadata associated with it. So here we have the trending Git repos for GitHub. Specifically, we filter out the language for Java, and then we have the options for both the month, the week, and the daily trending. So here over in our web scraper, we simply use BeautifulSoup. We grab the URL that was listed here, and we have the categories for monthly, weekly, and daily in this case. So I'm going to run this real quick, pretty quick run. And then it outputs the results over to git scrape trending.txt. So let's open that value here. So then here we have all the trending for that specific month, week, or daily, making sure we also don't do any repeats for that one as well. And then similarly, we also pulled from just the general Java topic. So this one takes a more robust time to run, so I won't run this now, but at the time of scraping, this is the results that we get from here. So all these projects we got from GitHub and purely open source, so you can look at them yourself. But then we would feed this results over to Rivew's like CryptoDetector and then go from there.
So here we talk about how we use the Rivew tool for detecting the files which uses cryptographic APIs. So what we do is, so Rivew is a tool that can detect cryptographic users from files based on the API users and also the keywords. So what we do is that we run Rivew for a specific project. For example, here we are running the Rivew tool on RX tool project. So here it is running all the analysis, and after that we get a file, JSON file, which contains all the file paths and the heads. The head says the type of evidence that it has seen. So it is using PKI, so private key. So So that's how it is using. We know that this project is using cryptographic API.
Then to help aid our survey, we also pass the code to static analysis tools when relevant. A static analysis tool simply analyzes source code or compile versions of code to help find security flaws. This is good for initial passes, but most tools generate false positives. The tool we primarily use was SPOTBUGS, which is both an Eclipse plugin and a command line tool that analyzes jars for any vulnerabilities. We also investigated CryptoGuard from the same researchers who made Crypto API Bench and exhibits a really high accuracy rate, but found difficulty setting up the tool in our local development environments. So here we have SPOTBUGS being downloaded on my local machine here. I pulled it from the repo and I'll be running it on the Crypto API jar that is defined in another folder. So here's the invocation to run SPOTBUGS. We simply just run it with the jar from SPOTBUGS and the jar that we want to analyze. I'll be redirecting the output to SPOTBUGS, so let's run that now. Since this file is pretty large that we want to analyze, this particular run of SPOTBUGS is going to take a while. So just wait a minute. Okay, now that the file has been analyzed, we can open up in the other file here. So it has created a lot of entries here. It lists like the severity level from medium to high, why specifically it's flagging it for cryptographic misuse. But the one that I do want to focus on as an example, have it highlighted here. In broken hash AVPS case 2. So it shows that it has reliance on the default encoding for this particular library. So if we open up here, we see that it is indeed falling back on some default encodings in this case. And it shows that MD5 is being used as well. So again, SPOTBUGS is used as a final pass for the survey and to kind of reinforce our results that we received from the manual inspections.
Next portion, I'll talk about the evaluation and the limitation and the feature work of this project. So we manually analyzed 18 projects for this work, and we only considered the 16 cases that was described by the Crypto API bench paper. So let us look at the projects one by one. So the first project that we looked was Arthas. So Arthas is a Java diagnostic open source tool which is provided by Alibaba. The tool is quite popular. It has 25.7 kit stars and 132 contributors. It has secure cryptographic uses. We found evidence of certificate validation, SSL socket, and symmetric cipher API uses. Here's an example code where we can see that SSL socket has been used. The second project is Canal. It analyzes incremental logs based on the MySQL database to provide incremental data subscription and consumption. The project is developed by Alibaba, which is an open source project also. So it has 18.7 kit stars and 136 contributors. We found that it uses secure cryptographic key, password in PB, SSL socket APIs. But we also found that it has insecure cryptographic hash API use. So in the example that we took from the Canal project, we can see that it uses MP5. From the Crypto API bench paper, we know that it can be broken. So DataX is our third project. So DataX is a widely used offline data synchronization tool or platform in Alibaba Group. It has 8.7K star and 31 contributors. We found evidence of secure use of cryptographic key and symmetric cipher APIs, but we also found evidence of insecure use of modes of operation APIs. In the example, you can see that it uses ECB. So ECB is insecure by cryptographic API bench paper. So we found that this project uses this vulnerable mode of operation API. Next, we talk about FastJSON. FastJSON is a Java library that can be used to convert Java objects into their JSON representation. It has 23.3K stars and it is used by 280K packages. So it is a really popular tool. We found one API misuse, but I think we found that in a test file. So we think that this is because they wanted to test vulnerabilities. So that's why they put it in the test file. That's why we don't include that in our study. Our fifth project is Antler. So Antler, which is the full form of Antler, is another tool for language recognition. It is a very powerful parser generator for reading, processing, executing, or translating structured text or binary files. So it has almost 10K stars and 254 contributors. So it is a very popular open source tool. We found that it uses insecure cryptographic hash API. So in the example that we took from the project, you can see that it uses MD5 for hashing, which is known to be vulnerable. So next, we talk about the Dolphin Scheduler project. So Dolphin Scheduler is a distributed and extensible workflow scheduler platform with powerful DAG visual interfaces. It has 5.7K stars and 200 contributors. We found that it has secure cryptographic key API users, but we also found that it uses insecure cryptographic hash APIs. So in the code snippet that we took from the Dolphin Scheduler project, you can see that it uses MD5, and we know that MD5 is vulnerable. The next project we talk about is Apache Demo. So Apache Demo is a high-performance Java-based open-source RPC framework. It has 35.2K stars and 386 contributors. We found evidence of secure use of cryptographic key, post and verifier, certificate validation APIs. But we also found it uses insecure cryptographic hash API. So in the code snippet that we took from Apache Demo project, you can see that we found that it uses MD5 for hashing, which is known to be vulnerable. Next, we talk about Apache Rocket MQ project. So Apache Rocket MQ is a distributed messaging and streaming platform with low latency, high performance, and reliability, trillion level capacity, and flexible scalability. So it has 14.2K stars and 234 contributors. We found evidence of secure HTTP protocol API in this project, but we also found that it has insecure cryptographic hash API and pseudo random number generator API misuse. So if you so the code snippet we took from the Apache Rocket MQ, if you look at that, you will see that at line 22, it calls the Java util random API and then it uses it. So this random number generator is vulnerable, you should always use Java util secure random. That is secure. Next, we talk about ASA token. So ASA token is a lightweight Java permission authentication framework, which mainly solves a series of permission-related issues. It has 2.5 clusters and 470 forks. We found that it has insecure cryptographic key, symmetric cipher, and cryptographic hash API misuse. So we provide 3 examples of that. First one is that it has been all of these 3 lines are taken from 3 separate files. So the first file, first one says that it is using SHA-1 algorithm for hashing, which is vulnerable. And secondly, it is using ECB, which is a vulnerable cipher, mortar operation cipher. And the last one, we can see that it is using MD5, which is a vulnerable hashing algorithm. The next project we talk about is Halo. So Halo is an open source blog publishing application. It has 18.8K stars and 61K contributors. We found evidence of insecure cryptographic hash API uses here. So if you look at the code snippet that we took from Halo project, you'll see that they're using the SHA-1 algorithm for hashing, so it is vulnerable. Next, we have Jenkins. So Jenkins is a leading open source automation software. It has 17.3K stars and 684 contributors. So Jenkins is a really popular tool, which has been using for many automation tasks. So we've found that it has insecure cryptographic hash API users. So if you look at the code snippet that we took from the Jenkins project, you'll see that it is using MD5 for hashing. And we know that MD5 is vulnerable. So next we talk about the Mall project. So the Mall project is an e-commerce system, including a front-end mall system and a back-end management system implemented based on Spring Boot plus MyBetis and deployed using Docker containers. So it has 48.9 clusters and 21K contributors. We found that it has pseudo random number generator API misuse. So it uses the Java util random API. So any random number generated by this util random API is insecure. We should use security random API, which is secure. The next one is Meowsha. So Meowsha is a design and implementation of the Spike system. So it has 20.4K stars and 5.2K forks, so really popular tool. So we found that it has it uses insecure cryptographic hash APIs. So if you look at the code snippet that we took from the Meowsha project, you'll see that it is using MD5, so which can be broken. So so next we talk about the Ciata project. So Ciata is an easy to use, high performance, open source distributed transaction solution. It has 19.4K stars and 208 contributors. We found evidence that it is using cryptographic key APIs wrongly. So if you look at the code, correctly. So if you look at the code, you'll see that it is using encoding key spec, which is the right way to do it. Next, we talk about the Signal server. The Signal server, the server supporting the Signal private messenger applications on Android, desktop, and iOS. So it has 6.6 stars and 20 million active users. So the Signal app has 20 million active users. So really popular app that is getting popularity day by day. So we found that it is using secure password in key store, certificate validation, and symmetric cipher APIs, but it is using the cryptographic hash API wrongly. So if we look at the code snippet that we took from the Signal server project, we can see that it is using SHA-1 algorithm for hashing, which is vulnerable. Next, we talk about the Spring framework project. So the Spring provides everything that is required by the Java programming language for creating enterprise application for a wide range of scenarios and architectures. So it is a really popular framework that has been used by many projects. So it has 43K stars and it is being used by 163K packages. So really popular tool. So we found that it is using secure HTTP protocol APIs, but we also found that it is using cryptographic hash API wrongly. So if you look at the code snippet that we took from the Spring framework project, you will see that it is using the MD5 hashing algorithm. So next we talk about the OK HTTP project. So it is Square's meticulous HTTP client for JVM, Android, and CrowdVM. So it has 39.9K stars and it is being used by more than 37K packages. We found evidence of secure cryptographic key certificate validation and SSL socket APIs. So here's this code snippet that we saw, which is secure. Next, we talk about the RX tool. So RX tool is a collection of Android tools. It has 11.8 4K stars and 2.8K forks. We found that it is using the cryptographic hash API to API wrongly. So we found that it is also using the MD5 API for hashing, which can be broken. So next we talk about limitations and the future work of this project. So the limitation of this project is we use cryptographic bench rules for detecting API misuse. So we do not guarantee that they cover all the cases. We are just following the best literature rules that we found. And we manually analyze the files according to the rules. So there might be some human errors. In conclusion, we systematically analyzed 18 trending projects to find cryptographic API uses. We found that 14 projects has at least one cryptographic API misuse, and the most common API misuse is cryptographic hash API misuse. The future work of this project includes measuring the impact of discovered cryptographic API misuses, and also we plan to interview the project developers to understand the gap between the theory and the practice. That means why the developers are not correctly using the cryptographic APIs. So that's include conclusive projects. We'd like to thank the TA and the course instructor for this wonderful class. We have learned a lot from this class. Thank you.